How do I... Here we go. Then we can come over here and we can try it. We can see what the hell it looks like. You guys can't hear anything, so I can check how it sounds. But it looks like it sounds good. So I guess that means we're live. And since we're live, we're going to go announce that we're live. Let's steal red circle. Live on YouTube. We're going to steal Soding here. Getting around to Lexing. Laye source this time. Boom. We'll even do yoink. That just looks stupid. We're just going to leave it at that. And it's the announcements channel, so all I have to do is publish it. And it doesn't matter if there's a ping it a ping it a. So cool. Let's get rid of this. We have a lot to look at, so I'm not going to spend time on it. And I'm going to go reply to somebody. Hello. Let me know if the mic sounds obnoxious and we'll tweak it a little bit. Okay, so I've done entirely too much since we last streamed, and I have a few things left to sync. So this doesn't matter as much. I think I only changed that one line to if source is shared. This should have one new function. It does. Okay. Well, yell at me if it breaks or something. What other files do I need to look at? This, I think, replaced some things. So we added the compound and assignment and some other things. We added a lot to this one, so I don't know exactly what. I think that's all I did was, so let's just git add.git commit, start defining type equality and some other small changes, something like that. And we'll update that before we get going here. I don't know why it keeps insisting I relog in. But I will log in anyway. Okay, so we are ready to go. I've done a lot of scaffolding out of things that we can use for lexing and parsing. We're not going to go, like, it was a lot of grunt work just setting up data types, basically, and a lot of helper functions I figured we might need. So as they come up, I'll go over it. If anybody wants to specifically ask questions like, oh, what kind of syntax tree is this? Or like, how did you build the syntax tree? What the heck is this X? And just ask, and if I pay attention and read your question, then I'll answer the question. Git config global. It might be... I don't really want to config global it, but maybe I will. I think it's set to... I thought it was set to cache what I was doing, but it might not be. It's not a big deal. It's only every few days at worst and every few weeks at best, so... Anyway, so what we want to do is go into our parser.c, where I've done just a bit of grunt work to set up a parser entry point and a lexer entry point with any necessary asserts generating our starting data. And we're going to start lexing from here, I think. So let me go ahead and get knob and outlier. We have a build error to fix first, because these in, I believe, data string. What line was this? 35. 55? 35? Nicely shared 35 to 55. Oh, shared, not data. Duh. Shared here, right? Because this needs to be nice. string equals a string and b string. Didn't do that correctly. Should have checked that it built before. It does now. Get this. Yeah, get that. A fix bug with double equals. Typo. Not really a bug. Typo. Okay. See, it caches temporarily. It's just not a long cache. Anyway, so now that we've got it building, it's using this tokens.laye file by default. We're not parsing any command line. So, also, since the last stream, I didn't mean to make a new window, we have an update to just the Visual Studio version of the syntax highlighting here. So GitHub -VS Code. Zedrich has made a couple new releases. This needs to be reverted. He's rewriting the parser for that sometime soon. But based on the discussed potential changes in the first stream to my original goal, the syntax highlighting has been updated. So if anybody wants to follow around, write some pretty looking Laye code throughout the duration of the project, you can always go there. I will probably add this to the description here. Edit Visual Studio Code. We'll just call it VS Code because nobody says VS or Visual Studio. Laye extension now in the description if anybody wants it. What's your idea? What's the idea for your language? Parser. So we need to, right here is where we're going to start parsing. So the current character, we need to define some helper routines to consistently know what character we are on, where we are in the source file, and moving around the source file. So we could say Laye current are from a parser, and that is probably okay, but also we just have p current car, which might, like, I think an unsafe access to that is probably fine. At the start of the parsing routine, we prime the first token, so that should probably also mean we have to set up our parser to have the current car primed as well. So let's see, parser, source, whatever. Let's go ahead then and say dot current car equals source text sub 0, which we shouldn't actually do in here because it's entirely possible that the text is empty. Hello, Jose. If source text dot count is greater than 0, then we can do p dot current car equals source text sub data rather sub 0. Get the first character primed. The source position, lexer position is already 0 by default. The source is assigned the source ID okay, so context. We're missing context module. Source ID doesn't exist, so dot source ID is source ID. Then if we have something, go ahead and do this. So the next token. What we wanted to do with EOF, we probably want to calculate EOF. No, because we're doing it in the parser here. So we're just going to say, hey, while we have a token, while we have a character. So if C is ever 0, oh, that's a good point. If ever we wanted to allow a 0 byte, which we very likely don't, then we would want to put end of file check in a, like in a wrapped thing, right? Because we probably don't want a null byte in the source file. You're never really going to see it without special characters rendering turned on, right? So for most people, a null byte is useless. And for anybody who wants a null byte outside of a string literal, they're probably crazy. So I think the semantics of Laye source will be null bytes are disallowed. until we have a valid reason to change that. It'll only be changing the lexer, so it's not a huge deal. So let's start there. Switch on our character. By default, we're going to just report an error and break, but we have to consume the character. So let's write a function to do that. Static Laye parser p. So then we want to say if p lexer position is already greater than or equal to p source count, text count, just return. Absolutely nothing to do. Just in case, we will set p current file to 0 and p lecture position for checking. Token. Oh boy. So it sounds fine through my monitor. But I noticed when I was recording things that it would occasionally just decide really hard to talk while I'm hearing myself. It would occasionally just decide to go all stuttery. Is it like I need more information to know what's going on? I could remove the noise suppressor. Or put it somewhere else. Like we could noise suppress at the very end. Stuttery. Yes, it's stuttery. Well, that's no good. I have nothing to sidechain. Output gain, we're doing a gain afterwards, so that's fine. None of this looks bad to me. This will keep it from clipping. Like I could put the noise gate somewhere else. Like if I put the noise gate here, is that significantly worse or better, or is it about the same? I'm gonna turn on monitoring again. It's not gonna matter that much, because like I said, the monitor sounds fine to me. I think it's something to do with the way it's encoding it into the video, or into the stream, or something. I've never noticed it while monitoring, only when I record it and play it back. So I can't tell. About the same? Yeah. Well, that sucks. If I remove the suppressor, this sounds way noisier. But does it fix the problem? You can hear me clicking now, which is no fun. Hello. No, I'm trying to figure out a stream stuff. Okay. Yeah, I assume this is worse, but I'll let you guys tell me it's worse. Bung, 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 bung. I'm gonna keep this on. And it might not be a setting that I can do there. Audio. Don't need hotkeys. Output. Maybe it's the audio bitrate? I'd probably have to restart stream if I change this. Better now. Interesting. Like better than before? Or still bad? What do people recommend for like my audio settings here? I mean, like, bitrate to like 320. So 160 is fine for Twitch. I don't know what it is for YouTube. If it's not stuttering now, then we'll just call it fine. Let me turn off the monitor again. That's filters. Advanced, monitor. Cool. Well, keep me posted. We're back to advancing. If we're past the end of the source text, then all we need to do is do this and return. If not, then, well, let's increment it no matter what, and then set it equal to the count, just so we have some kind of consistency. Cool. So then what we'll do otherwise is the source text data sub, whatever the position is. That, oh, I went way too far. Then we're not handling new lines here. We're not handling much of anything, really. So if we're not handling new lines or positional stuff because we're calculating it later, then I think that's all we have to do for an advance. Check for end, make sure 0, get current car. So Laye car advance of P first. Then so I don't like duplicating this kind of code here. What normally I would do is fall through a case and do final token setup at the bottom, where we can assert that the parser, the lexer, actually got us a valid token. And that we can assign the length here of the token, so we don't have to pre-compute that calculation all the time. But I think here, we got to do it here so that we can use this to report an error. This will be p context. We want in context of the location, which is this location. And then we want to say unexpected character, unrecognized, invalid character in Laye source file. And it's going to have the location information with it. So we're not going to worry about anything more specific yet. If we encounter an invalid character, I think we're just going to recursively call next token. Right? Because we don't want to just return completely bad token. So eventually we might have a case here as well that bypasses this error handling and checks for other things. But for right now, that's all we got to do. Let's do some really easy tokens first, because they're in the front of our tokens test here. All of these single character stuffs, and then we'll try to get the comments. So we want to case this. For a single character comment, we need P, we need token comment. I need to turn my phone on do not disturb and verify that none of these things are important. That's good. Does anybody need me urgently? If not, we're do not disturbing. That. Cool. Token kind equals, we shouldn't need an explicit cast. We're just going to say it equals C. Then we call it advance. So for regular ass single token characters, that's all we've got to do. Anything that can have multiple characters is more complicated. which we can look at with, let's start with bang. Bang could be two different tokens. It's either this or it's not. And what I'm going to do actually is for consistency, I'm going to do this. So this is to be like this, because then what we're going to do is if P current car is equal to equals, then we do something else. We do this. Message retracted. Stuttering again. But what do I do? How do I fix? It's not stuttering in OBS, so I can't. There's nothing I can do to check on it without stopping the stream. Or I guess look, if I start recording here, then I can let it go and I can stop recording and I can go somewhere into my file system, like here, here, here. Yeah, it's stuttering occasionally there, so that sucks. But why? It might be because I'm doing that. Hold on. Let's do some live work here. I've got these two things. We're gonna delete, and then we're gonna switch back to this, go back to its filters, and reset up some filters. So step 1, noise suppressor. Cool. Step 2, regular ass compressor. Default settings, good. Step 3, gain, okay. I had this at 8. Step 4, limiter at neg 3. I don't know why I'm doing it this way, but fuck it. Neg 3. And finally, the noise gate with the default settings. So, what about that? How does that sound? Hide this. And we'll just leave it at desktop audio. I was trying to be fancy and put them over here, but apparently that fucks everything up and it's a bad idea. Yep, that sounds a lot better in the recording too. So, hey, we're gonna just do it the simple way, I guess. Cool. All right, back to writing a lexer. We don't need anything else fancy here, but what we do need is this, and then token kind equals Laye token bang equal that. So that's our 2-character case. We'll eventually have cases for 3 characters and potentially more. I don't think we've got any 4-character operators. We could have a 4-character operator if we wanted floating point operators for fancy things like, hear me out, if we had not less than or equal to not less, greater, equal, some shit like that, but no, not worth. No stuttering. Hey man, about your project, you are rewriting, or is it continuation from earlier in videos? It's a rewrite from the earlier videos in the channel. It's a little complicated how we got here. I was working on a version of the compiler. I went and worked on a different compiler with somebody else. I took a break from that compiler to start the compiler series that was the first series on this channel. And midway through, I didn't really like the way I was handling the compiler. I kept working on it off stream to see if I wanted to keep doing it, and I didn't the way that we were doing it. So I went back to the other person's compiler for a while, a couple of months, got Laye to the point where it was almost executing reliable code, and then was just like, I don't know. There's some stuff going on, And I'd already been thinking, like, really the vision for Laye was that you could just compile it with a C compiler and eventually with the Laye compiler itself. So it didn't make sense to be rewriting it in C++, and there was a bit of drama going on top of it. So I just decided, okay, clean slate. My goal for Laye is all you need is a C compiler to bootstrap yourself a Laye compiler. And if we're lucky in the future, we're going to also be compiling the original Laye compiler with another Laye compiler, because I want to be able to parse and compile C to at least some degree. Anyway, so now we're back here. That's the primary goal. So it is a rewrite. We're focusing on Laye instead of the original part where we were focusing on C. We're not going to be bootstrapping a C compiler just yet, but it is still a stretch goal. So maybe by the time we're doing some parsing and semantic analysis of Laye, we can go back and revisit the C preprocessor and lexer. I will probably keep most of the original code for the C preprocessor and probably the lexer because they're kind of intertwined. So you might see that part come back, but since we're doing Laye, I figured we have no reason to use the old code. I already kind of want to do things differently, and there's nothing really to preserve from the original code. I was doing it kind of wonky, pretending that it was going to be really easy to parse with a shitty C compiler that we were writing. It wasn't going to work. Anyway, so this is built a little bit more robustly, a little bit more thought out, less optimistic that we'll be able to compile it ourselves anytime soon. Anyway, so we're moving on from there. Anyway, so bang goes into modulo. Modulo. I do this. Oh, it really doesn't like that. Because it's not... Aha, because it's a typo. We've already caught a bug. So if I did this, then I can. So then we're on modulo. Yes, after Sema, we're going to be doing an LLVM backend. Eventually, I would like to do other backends, but the easiest way to get it working and test it and debug it is using an LLVM backend. We are going to be, I put it in the README as like one of the only things that I know we're going to require. Technically, you could use any C compiler to compile the Laye compiler for whatever like flags we're using. I think right now I'm requiring C23 for just because, but we're probably writing like C98 or C11 code. So almost any modern compiler will compile this, but I think we're going to be emitting LLVM IR as text in a format that Clang 18 understands. So that will be a hard dependency for now. WCC2, what is WCC? So then this would be mod equal, did we call it mod percent equal? Called it percent equal. Then after percent, we have ampersand. Then this is token amp equal, probably. Amp equal. Just do all the lazy brunt work, because all we're doing, skipping characters that we know, assigning something to it, calling it a day. Star turns into star equal. That's an ampersand again. Star equal. That is a star equal. Star equal. Cool. For these other delimiters. Hey, my roommate is funny. For these, I don't need the whole thing. I just want this. These are very explicitly very simple delimiters. So I'm just going to pair them up, put them all in the same case. I'll even put them way the hell here up at the top so that I'm not in the middle of all of my operators. So now we have or, pipe, and pipe equal. Oop. Pipe equal. After pipe, we have minus and minus equal. I could definitely write macros for these, but I really don't want to just litter my code with macros. After minus, we had equal. Equal has a few different cases, actually. This one becomes equal equal, but it could also be equal arrow, could be equal greater, like that, right? Then we can do plus, which will be just like minus height, the others. Plus equal, I believe it's plus equal, it is plus equal. After plus, we have colon, which can be colon or a double colon. Okay. We have a semicolon, which is going to exist on its own. Stop hitting all the wrong buttons. Semicolon. Comma and dot. Comma is just going to exist as comma. Dot is going to have a special case here where we want to, if this token is dot, then we want to advance. And then if it's dot again, then it's token. Did I call it triple dot? Did I not copy over my triple dot? Oh, I don't need a triple dot because we're not parsing C. Duh. So for the time being, dot is exactly the same as comma. Var args are handled differently. After dot, we have slash, which is going to need an equal. So we'll grab our equal. Slash and slash equals. Then we'll have less, greater, and question. Less and greater are going to be a touch more complicated. Less has a few cases beyond just equal. Less equal. We could also do less less. And if we do less less, then we also have to check for less less equal. Right? So if it's less less, so it could be less equal, less equal, less, or just less. I mean, yes, for now. Also, this one tilde does actually have an equal, so it needs this anyway. I don't know why I didn't do that. Braces are the obvious ones that are only ever going to be their own thing. There may be times where something like, I mean, these are also delimiters, so you know what? Fuck it, we'll bring up the colon, put it next to the delimiters. Then we can do what? Comma, semicolon, dot. Like that, sure. I really like Zig. I don't know anything about C3. Zig is actually very similar to what I've been wanting to do with Laye for a while, and I accidentally either unintentionally stole or came up with it very similar things to them after the fact. Zig is very close to what I want, but I hate its syntax, and I think the semantics are a little too complicated. I still really like the simplicity of C, and I'm not looking for lots of really big features. I'm looking for a handful of smaller features that make life easier, that you can build other nice things on top of. And that's a very abstract thing. I don't know exactly what that means or what to compare it against, I know. So, whatever. Odin, similar thing. I like Odin a bit. It does some things I consider questionable. I like the context system. I liked the context system when Jai did it, but it has its flaws. It's an additional parameter, so your calling convention gets wonky, and anytime you want to call into it, you have to set up a context to pass back in. Right, so it's harder to call from C. I really want C interrupt to be a big part of Laye. So the more emphasis I put on a context object, the less easy it is to call from C back into Laye, unless you do, like, just turn off the feature, which, why use it? So I think we're going to go with an explicit system of just, hey, pass an allocator around and pass anything else that you want around, and just put your data where you want your data, and we're not going to hide the data anywhere. I do like the Odin and Jai context systems, but I think they're just a little bit higher level fancy magic than I want. Zig's type system has a lot of things that I like. We're not doing everything that it does, but it does some nice things. The fact that it bundles a C compiler with it is fantastic. That's the plan with Laye, is to either leverage the system C compiler or use like LLVM or Clang libraries to do stuff in the future, or build our own C compiler, because that would be fun. Again, I don't know anything about C3. Yeah, I don't know. I don't know. I like the idea of a C replacement, or I wouldn't be working on Laye, but I don't like the word replacement. Like, I don't want to replace C entirely. Everybody runs on C. So I'm of the Zig mindset where we're not replacing C, we're just a step above C, and we interop with C really, really well, right? Because even if C dies as a language people write new projects in all the time, it's going to be like COBOL for the financial industry. Everything's still going to be written in COBOL for forever. Everything that we're using is still going to be written in C for forever. So we just got to accept that and embrace it. So I love writing C. I have no problem writing C. It does have its age problem, so I just want to make that less of a problem. Laye is very, very similar to C. I don't want to go quite as far as the other languages do. I'm rambling at this point, but like, I don't have any hardcore objective things to talk about. Got a case. Need a case of minus. Less minus. So then for greater, everywhere that we do this, we do this. Everywhere that we see this, greater. Greater, greater, equal. That looks good. Question is only ever going to be a question. So for now, we might end up with the question coalesce operator, so I'm going to leave it like this to make it easier to do that later. Equals arrow tilde equals. Okay. That just about covers all of the operators I want right now, I think. I feel like I'm missing some. This feels too easy. But yeah, this feels too easy. We probably missed something. But that's fine. So something else I want to do is decide how the hell I want to handle, because I would love to go ahead and think about right now if and where we want to store comments for the purposes of writing a formatter, for example, right? It would probably be very nice to allow the Laye compiler all of the syntax information from the get-go, so we can use that same data structure to write a code formatter. So normally I would just say fuck it, not worth it, and skip all of these. But I think we're going to put a small amount of time into thinking about it and see if it's worth it. So let's type def a struct. We're going to call it a trivia. Trivia will have a trivia kind eventually. But before we get to kind, we know a trivia needs a location as well. And I don't think for the time being I'm going to worry about storing any of the data in a trivia. So long as you have the location for it, then everything is fine. And a trivia is just going to refer to, in this case, comments in potentially white space. I don't know that we really want to store white space trivia, but comments are still syntactically relevant for the user. So if that's all we do is say a trivia is any syntactic or like, I guess technically quote unquote syntactically relevant non-syntax tree thing, then we can just give it a location, not worry about having a kind for now. We will want to eventually say, hey, this is a line comment, hey, this is a block comment, and here's the text value of it. So maybe we just do that now. We go ahead and store string text, right? And then if we did that, let's come up here and say define Laye trivia kinds of x with x line comment, x delimited comment. And then here's the not problem, but if I have nested block comments, I think the nested block comment is really just going to be part of the delimited comment, the parent one, right? There's not going to be a hierarchy of trivia. So a line comment and a delimited comment. I think those are the only two things that we care about for now. So let's format. Let's define with a cling format off, cling format on, type def enum Laye trivia kind, rabbit kind Laye trivia none, and then define x of n be Laye trivia n def x and Laye trivia kinds x, like that. If anybody doesn't know what this does, we're doing it a lot in here, so feel free to ask and I will explain what x means. So now what we want to do is have a static Laye token, not Laye token. We want a dynamic array of Laye trivia. And trivia probably don't need to be pointers. They're relatively small. I mean, like an int plus an int64. So that's 3 int64s. This will end up being so 4 int64s, unless this is padded, so it's going to be even bigger. So if I did this, then that would be going to be smaller. But this is going to be like 2 or 3 int64s as well. So I mean, if this is like 64 bytes long, that's not a huge deal. But maybe we do want to allocate the trivia on the heap. So let's say that we keep allocating trivia. We want to write a quick help routine for that. Where are we doing? Because we're not heap allocating tokens. Tokens don't exist for very long. So it just feels weird to heap allocate a trivia, but they will last longer than tokens, technically. So trivia. Let's not heap allocate the trivia. Laye read trivia. And we will want to know if it's leading or trailing trivia. So bool leading. Don't have defaults here. So we can say if it's already EOF, then we're fine. And the EOF token may get leading trivia. I think that makes sense. So let's say token leading, that is not how you spell that, leading trivia equals Laye read trivia true. If we hit the EOF, then we return it, and it's fine. So let's go alter. We can union these for space reasons. We're only ever going to be accessing them at a time. So then we can say dynamic array of Laye trivia, reading trivia, and trailing trivia. So then at the very end, once we're done here, we can say token dot trailing trivia is read trivia false. And the reason we want to know if it's leading or trailing is trailing trivia here needs to be attached to this token only for as long as it's on the same line. But if we go down here, the next line of trivia is leading on assert, right? This is trailing on this, and this is leading on assert. So we want to know where to stop. We want to stop at a new line if not trading. If leading, ignore new lines. If not leading, new lines are significant. So we're going to grab the current car. This needs to take in parser of P. This needs to pass in parser. And we're going to switch C. If we hit white space, this is where we're also going to handle white space. I just don't think we're going to return a trivia for it. So trivia will be null, and we'll return trivia like that. So case space new line, carriage return, horizontal tab, vertical tab. I think that's really all I care about. We're going to Laye advance E. And everybody's going to hate me for using goto, but I'm going to say try it again. So for as long as we hit white space, we're just going to skip it and reswitch. Rather than doing recursion, which, if you have a fuck ton of white space, could be not fun, we're just going to back and forth here, back out of the jump table. If we hit a slash, this is where I very explicitly would love a peek. I don't need a peek very often, but I should probably peek. So let's just write it here. It's fine. Laye car advance. If the current car is equal to another slash, then hey, we're good. Else, if it's equal to a star, then hey, we're good. Else, p current car minus break. Doesn't really matter actually, because we're just going to break here. Not current car. This is where we want to. So we did this down here somewhere, didn't we? We were thinking about doing it, but I don't think we actually did. Yeah, no, we never actually did it. Okay, so I do want to peek because doing this would suck. So if Laye are peek P, then we Laye car advance twice in both cases. Really, we don't need to do it here. Depends on what kind of experience you actually want. If you want to just get from source to compiled code and worry about the front and middle pieces, parsing and type checking, just go with an LLVM backend so you don't have to think about it. If you really want to maybe use this as an opportunity to learn assembly and maybe to figure out how basic compiler optimization works, then try an assembly backend. Because you're not going to be doing manual work with instructions or optimizations for most of the front end of a compiler. You can, you just really don't have to. So if you're looking to learn optimizations and lower level stuff like assembly, roll your own assembler. It's going to be a little bit complicated, but you'll learn something, probably. If you want to learn about type checking and how to design the front end like the syntax of a language to be useful, then worry about just emitting to LLVM. I personally find the language design a lot more enjoyable than the backend, even though I still want to write my own backend of some kind that isn't LLVM eventually. I much prefer front-end design of a language. So from my perspective, I just need to use LLVM, right? Just depends on your goals. And here we really don't even need to do anything. We can just say while Laye e current card is not equal to 0 and e current card is not equal to a new line. Laye car advance. And I say that, but I really do want this because we want the string from wherever it starts. So we can say int 64t text start position is p lexer position, end position is p lexer position. So then we can grab a string view and turn the string view into a string. So let's just say string view line comment text equals, I don't know if I have a routine for this. So I want string view slice. Yeah, I don't have a slice. Do I have a string slice? I don't have a slice for a string either. String. So we have, hear me out, p source text dot whatever. And text is a string. So I want string slice as a function. So we can take this and say text start position. And then the length, I prefer my length to be, or my second argument to be length, not end position. So it'd have to be text end position minus text start position. And that's the length that we're going for. Let's go into LCA string, LCA stir.h. We want LCA string view, LCA string slice, LCA string s, int 64t, offset int 64t length. And then here we're going to say Laye trivia, line trivia. Yeah, using C++ if you want to interop with the LLVM libraries is probably a good idea. You may end up needing to build LLVM yourself, though, which not like the worst thing in the world, but I mean, just yeah, depends on how you need to consume LLVM. If you're on Linux, you can probably get up-to-date versions of the libraries without having to build from source, but also if you're on Linux, it's easier to build from source than on Windows anyway. So just yeah, something to think about. Line trivia will be something I'm going to initialize up here, actually. Let's say line trivia, Laye trivia, trivia. Oh, because we're looping through here. We're going to say while p current card is not equal to 0. Default break needs to be exit loop. Again, yes, I'm using goto. I don't use it that poorly, it's fine. Message redacted. Why am I... There's a message retracted. Message retracted. Why... Am I getting notifications that things are coming through poorly, or like, is this just... I don't think I've got anything like auto whatever. You guys deleting your messages, or is my YouTube chat being stupid? Oh yeah, over here. It's just going to format out. I was going to fix that in a second. So string slice needs to be added as, so right before format. Find string slice SOL. Shit, add a look. LTA string slice SOL. Beautiful, see? So now we have string slice. We'll have to go implement that in a second. So here we can say trivia, our push trivia. Trivia. If I do this, it's not actually going to be happy. So we'll go back to Laye trivia line equals this, and then we'll push line trivia like this. Dot no semicolon. Dot kind equals Laye trivia line comment dot location. Here is where we want location dot source ID equal to p source ID dot location dot offset equals, yeah, so here we can actually put this right here, right? And this is the offset. Then we can say line trivia location length. Ooh, actually, give me that back. The trivia needs to start at the very first token character. So now we have the text start position and the text end position. I tried to build LVM 18, of course, but I couldn't. I don't recall having that issue myself. I do have my own build of playing an LLVM. The Clang that's running here is Clang 18 built from source. So I have successfully done it myself. I just don't remember what issues I came up with. I didn't write them down like I should have. So I might not be much help. Line trivia dot location dot length equals line comment text count -2 to account for line trivia dot text is going to be string to string to string because we sliced it. Line comment text. Right, and then this text is a string. This is an allocator, right? So that's going to be p context allocator. Oh yeah, do that. Make sure user local bin is in the path. So then I don't have anything else I need to do with it. So while I'm here, I should probably just use this syntax here, because I forgot you could do that, honestly. Cool. That's cool. Eat everything, turn it into text. So we just need to implement string slice. LCA string view, LCA string slice, LCA string s int64 offset, int64 length. And then we're going to start off assuming all the values are correct. So return LCA string view of dot data is s data dot, well, it's data plus offset dot count equals length. And there's not anything else in a string view, data and count. So what we want to do then is, I think instead of adjusting anything, we're just going to say, hey, assert that offset is greater than 0, greater than or equal to 0, and that it's less than s dot count. Well, I guess it could be or equal to count if we want to slice off the end. But then we want to assert that length is greater than or equal to 0, and offset plus length is less than s.count, which I guess means that this is useless. Offset length and then offset plus length. Let me just return this. If we want to do fancy automatic shrinking of the slice space later, we can. But for right now, not necesario. Okay, so now we've sliced the data. We have got a string view, toString of the data. So we've allocated the text into the trivia. Now we have a line comment trivia. So here, let's do the same thing for our block trivia, which is a delimited comment. Starts here. We need source text start position as well. Here, and whatever we do at the very end needs to be the same as well. So now all we have to do is think about our int nesting, which will start at 1, while p current car is not equal to 0, and nesting count is greater than 0. So in order to track this, we need a car, last car, which is going to be 0. So last car equals p current car, easy. What we want to do first, though, if p current car is equal to slash and p and the last car is equal to star, then nesting minus minus, right? Nesting count. And then just if nesting count is equal to 0, right? So this is the end of the loop. So then I don't really need this. I'll leave it in there for redundancy, but this is the exit condition for nesting count. So then we want to say if nesting count is greater than 0, write error in p context at the full location. So we should go ahead and set the location information here and get line trivia location. It's not line trivia, though, it's block trivia. Block trivia dot location. Unterminated delimited comment. We'll make these errors better eventually, I swear. They just have to work before we can figure out what needs changing. So, oh, I think I ran over one of my cables. I did. So, now all we got to do is last car is whatever. Advance, right? Now, oh, we need to increase as well. current car is a star, and this is a previous car was a slash, then nesting count plus plus. And so here is the problem. If I do this, we're already going to skip the first one, so it's never going to close. That's correct. But if I do this, that's incorrect. This needs to be opened and then closed somehow. So if I do current thing is this, then it's not going to be happy, because we're going to say, hey, cool, the last car is still this. So let's say else if, and then else. If it's neither of the above, we can do this. So then in this case, both of these cases, last car is going to be 0. And in this case, it's going to quit early. But no matter what, actually, we do want to advance. So we don't actually need that. That's fine. This looks correct. Start off with a nest because we have the start. If we hit the end, reduce our nesting count, break. Cool. If we hit 0, then nesting count won't have changed. We'll get the error. Error. Here's the problem, though. This needs to be -4 if we hit the end. So we'll say minus nesting count greater than 0 or just because I'm not handling this entirely correct here. But if we got rid of all of our nesting, if we got rid of all of our nesting here, then we have the starting 2 and the ending 2 characters containing all of the text. So that's 4. If we have something left open, then it's unterminated, so it's only the first 2 characters. We just don't want to keep track of like 5 different source positions, so this is probably our best bet. Then this should just go ahead and be called block. Block comment text. Text start position minus text end position, which is here. Ah, yes. Yeah, this is the problem. So this is where we want to say it's -2 or 0. And then here, block trivia location length is, we're going to recalculate. Maybe position minus block trivia location offset. So the actual length recalculate from the start to the end, but the text end position is the current end position minus the last 2 characters if they exist. Okay. That makes sense. That makes sense. That makes sense. So now we've got comments as delimiters. So now I need to implement peak. Static car. Oh, this is void. Completely missed that. Static car. Laye car peak. Parser p. Let's say int 64t. Peak position is p lexer position +1 if peak position is greater or equal p source text count. Return 0. Return p source text data sub peak position, like that, right? Cool. Are there any build errors? No build errors. There's definitely something I fucked up somewhere, but it's trying. That's interesting. We have done something quite wrong. It's building without warnings, though, so hey, that's cool. So, invalid Laye token kind. Let's start with fprintf, standard error. And we'll just say lex mod c new line, and that will be c. So it hits tilde. And then it never prints that again. So when we hit tilde, this is after parsing leading trivia. So it's good that it gets there. And these notes are coming from, by the way, the parser entry, I believe. Yeah, from the parser entry. It's just looping through here. So while it's not EOF, it will print. And so what I forgot to do is interesting that the assertion failed there. So that's why you see context 61. Get source. The source ID is wrong. That's interesting. Right, because what's definitely one of the problems here is we need to get the next token. This token kind, completely wrong. Invalid, I believe, is 0. So it never updated. Oh, you know why? Laye token equals whatever. So in parser, we have p token. But we don't want p token. This is, I wrote it as if it were returning a token. This needs to be void. And at the very end of the routine, we need to instead say p token is token. Okay, that's still fucked up. But there's some part of the problem done. So where our parsing routine here is wrong. That. So token should not return a value. Return token. Where else are we returning the token? Oh, way the hell up here. Right. P token is. That's trivia. P token is token return. Okay. Now it's still failing somewhere here for some reason. It made it to plus. Made it to here. Which is roughly the same number of things it attempted before it failed before. So something is altering our source ID. Otherwise, it's parsing or lexing all these tokens correctly so far. So we can remove this for now. So why does it not like that? Source ID in a module, source ID in a parser, p token location. We're going to assert p token dot location dot source ID is equal to p location p source. It's not a pointer yet. Source ID. Does that get hit? That doesn't get hit. So context 61. Let's just see what's going on there. On line 61, Laye context get source. Okay, source info location. Print location info. Where else are we using get source? I mean, this is probably where we're coming from. Key token location. If I write note, right, because then we print the location info here. So this is probably what we're hitting. If I fprintf writing location source ID mod D, writing note, let's just see, writing note. And it's not mod D as much as it is mod LD. P token source ID. Oh, standard error. The source ID isn't changing. So are we changing the context sources count? Mod LD R count context sources. What? All right, so back in context, 61. Fprint out. Mod LD question less mod LD. Source ID R context sources. What the hell is changing? So this is still at the same location, 61. Do we have an error? 61 fprintf. Integer to pointer conversion. What? Oh, because it's fucking error again. Why is it 0? What the heck? What the heck? What the heck? So the assert is right, and this context is fucking wrong somehow. Oh, how? How? Oh my god, I would love to have an interactive debugger installed and set up. Like if I hit this, we don't want to debug just the active file, right? We want a new configuration. But I don't know how to do that right now. So what could be messing with the context? What would be setting it to 0? Anybody knows a good debugger extension? I just tell it to do this. Current working directory. Here. No environment. And then I can come over here. I can just set a breakpoint and see if this does anything. I just know. Take abort. Pthread kill. Are we in main? No, it stopped. So just hit the assertion. But there's no source information. So I need to make sure it's built with debug information. Knob. I think like that. Cool. Now I can try debugging again. Did I do it? I did it. We have debug information. Let's go. So I'm just gonna let it run. It's gonna hit this. We want it. So get source location here, right? Context. Is completely 0. Except for this. The allocator function is 0. Offset 30. Length 1. So it got the correct location information. Wait. Okay, that's fine. This is at 555555555. Don't know what that means. Okay. Print location info from right note. Get message might have something. Oh, it really shouldn't. I wonder if it's hitting a reallocation issue. Laye parse. Right. So, like, what is module now? Also a 5555555. All right, so context up here has nothing in it. It's null. Context allocator doesn't really exist. And that big number definitely makes me think that we're overriding it something somewhere. I don't know how. So let me start by restarting, hitting this breakpoint. Context is at somewhere. Lots of 5s, 63470. And then if we continue, it's still at 63470. So something is simply overriding the memory, not the pointer, and we don't know why. We know we're hitting it after hitting plus, right? After hitting plus and returning something, we're hitting it. So let's put a breakpoint on this. Let's launch the debugger. So token kind is Laye token tilde. Okay. Continue. Bang. Percent ampersand star. Open close, open close, open close. Pipe minus equals. This should be equals. So then we're going to parse plus. Plus is here. So at this point, what does context have in it? Still has all of its data. So we're going to step into next token. And what's over? 10 is over, 11 is into. 10 is over, 11 is into. This puts us here. Kind is colon. Okay, P. Okay, P context still has data in it. Okay. Over. Over. P context still has data in it. Over. Over. Context still has data in it. Into. Out of. Into. Context still has data in it. This still looks fine. So in write message, or get message here, I think calling string v format might be the problem. So I would love to go into string v format and continue until I hit it. So LCA temp vs printf has this allocator from the temporary allocator, right? Like nothing should be going wrong here. Let's check on here. Context still has data in it. Continue until I hit here. Context still has data in it. Step over, over. So here, context still has data in it. Use color true, sources, whatever. If I step over allocate, then everything's gone. Okay, that's suck. So this LCA allocate of the temp allocator is failing for us. But I don't know why. The temp allocator is doing things. I guess because it's using the same allocator. Okay. Well, we know it is a memory allocation error, which I kind of suspected. So LCA temp allocator is initializing with the default allocator. LCA context is initializing with the default allocator. Let's go into temp allocator init. Let's see what the fuck is going on. So our temp arena is at 63280. That's all fine. Blocks 63280. We look into that data. Interesting. Okay, I should probably go ahead and say that arena block what is 1, I think. That probably needs to happen down here too. Right, because then when I hit arena push, current block index. So what is blocks count and blocks capacity? Okay. Blocks count should probably just be block index. Yeah, because that's just never used. We may have to debug our arena allocator here. Yeah, hold on. So let me just flip this real quick so that we can see it. Let me in. Let me in. So when we hit temp allocator init, really what I want to do is kill all this and just assert that this is the case. So step 1, LCA temp allocator, LCA arena create allocator and block size, right? And then if we hit temp allocator function, it does arena push. An arena push on the temp arena user data here. Okay, arena count. Okay. Okay. First, just continue. Continue. Does doing that change anything? It does not. Still fails if we reallocate. So let's write quick test. And let's say, I don't know. Yeah, fuck it. Let's do this. Mem test mem return 0. So then what we're going to do is just for int I equals 0, I is less than 10,000, 100,000, I plus plus. Then we're going to say LCA temp, LCA allocate, LCA temp allocator. And we'll do a 64, 256 byte allocation. No, just void that. Allocate a fuck ton of shit. LCA and clear like this. And every step of the way, we can just insert context dot sources not equal to null. And the way that we'll make sure that context sources is not null is with r push context sources Laye source something. Empty source, nothing in it. So let's assert that it's not equal to null. R count this is not equal to 0. And at some point it's going to hit the boom da boom da boom. So if I debug this, we should fail. You know, we never rebuilt it. That's why. So we need our debug launch thing to build first. If I hit F6, right, I mean, like I can type knob down here and it'll die, but build. If I say run build task, figure a build task, create a task, others, knob. Build. Settings. Keybind. Keybind? Was that what I wanted actually? No. Keybind. Keyboard shortcuts. Build. Control Shift B. F6. Okay. What do you mean no build tasks found? I just configured a build task. Label build. Knob build. Why is this broken? Okay, it's not broken anymore. No build task found. Figure a build task, not build. Right there, it's right there. Build. Okay, so now we can see knob in the bottom. Temp arena doesn't exist on LCA mem 149. So temp arena needs to just be regular ass arena, first of all. And I have a feeling that this arena implementation is not actually great. So on arena push, assert that we have not exceeded block size. Then get the block that's the current block index. This reallocate is almost certainly what's fucking with us somehow. Okay, knob. Blocks count declared here. Yeah, blocks count. F6. Search. Oh, where is that? 108? Oh. Anchor command failed. Multiple definition. Ooh, right, because I fucking did this. Okay, so that fixes it there. Debug. Segmentation fault. Our allocator's gone. Wow, yeah, this is bad. So not only does it fuck up our context, which I assume is fucked. No, this is what? Okay, well, either this stream is going to turn into debugging an allocator, or I end up doing this off camera. Do you guys care about debugging an allocator, or should I do this off camera? User data allocator. So an arena block has the memory allocated and capacity. Something of note is I'm pretty sure. Ooh. Okay. We can have memory include our DS. Right, so let me include LCADS study. We're going to implement this in terms of a thing. So an arena block is just going to be memory plus allocated plus capacity, I guess. Fuck. That's probably still fine. But I can say dynamic array of blocks, first of all. And we have the block size. And then I'm just going to say fuck all of that noise. Right, and then if I build, we're going to have a fuck ton of errors, which is fine. The default allocator and the temp allocator. Default allocator is fine. Temp allocator. And I said it explicitly just because. Okay. Default allocator function calls malloc free and realloc. Calloc, I guess. Arena ensure block initialized here. This is kind of my problem. It's maybe doing that out of line. Temp allocator function here is going to say, look, create an arena. Okay, so when we init, we only init once. And this becomes an arena that we've created, which comes from this allocator. Our core allocator is the C standard library memory allocator, so that's fine. Our allocation function is this: assert that user data is not null. When we attempt to create an arena, we're going to say fuck this and say arena blocks is null. And arena blocks is going to start off as null. We're not going to pre-allocate jack shit. Right. So it's empty. What we're going to do is array LCA DA push. I'm going to use that version of it. Arena blocks LCA arena block. That's what it's called. What it's called? Yes, LCA arena block of a thing. But fuck it, let's initialize it here because commas. First block equals something. In our first block, Hope you guys can read this because it's grayed out and stuff. So we're pushing that. Ensure the block is initialized. Not important. Let's create a function to create a new block. LCA arena 8. And it's going to come from the arena. This. So then we can return LCA arena block. Create a new block, push it. When we create it, this is where we're going to do the ensure block initialized thing. So we want to say block dot memory equals LCA allocate arena allocated block capacity. Well, the block capacity is the arena size. Dot capacity equals also the block size. We haven't changed anything about this. So now we have memory and a capacity with 0 allocated by default. Then create a block, copies the memory. Blocks is null, which it already is by default. Okay, and return the arena. So there's only one block in it. So then arena push if count is less than or equal to the block size. Well, if it's less than. Yeah, less than. That's fine. So arena block is arena blocks sub LCADA count arena blocks. But what I have here is LCADA back of arena blocks. And then I can just say, give me a reference. Okay. So then, if block capacity minus block allocated is greater than the count, then we want to push a new block. Right. New block. A new block right here. And then if we do a new block, all we have to do is say this, right? Then result is block memory plus block allocated. Block allocated plus equals count, and result 0 count. Mem set should be fine. Arena clear, we're going to go for b equals 0. I don't know why I'm using b. We're going to say I is 0. Count equals LCADA count of arena blocks. I is less than count I plus plus LCA arena block is arena blocks of I. Block allocated is 0. It doesn't really matter as much. We're going to say LCA deallocate block dot memory may as well do that. And then arena blocks equals null and push another first block. think we want to say LCADA3. There we go. That. Then arena blocks is null, then do it again. Does this build? No. Oh, missed a comma in here. Then, so 68. Oh. Okay. Well, 150. So this doesn't actually work. Oh, because it's already. So yeah, we do just want back. I feel like that's wrong. That's definitely not what back is. That should be end or last. $154. Block equals this. Then do few arguments to deallocate. So LCA deallocate, arena allocator. Okay. Error has occurred. Exactly the same error. This kind of sucks. I might just rewrite this shit instead of refactor it. Um, writing your own memory allocators, people. Sometimes it's great. Sometimes, god fucking damn it. Let me just, for to be explicit, sub r LCADA count of arena blocks. Just gonna do this again. Maybe because I'm not heap allocating something and I'm indirecting the wrong direction. Allocated. I could dump the state of the arena. We could implement real quick. Void LCA arena dump. LCA arena. Just also say dump. Arena. So then we can come all the way to the bottom and say void LCA arena dump LCA arena. Then we're going to go through and say a couple of things. Do we have access to standard IO? We do. So we're going to say fprint f standard error memory arena. And we're going to say block count mod ld LCADA count blocks. We're going to do mod b here, which is going to take the rest of the arena. So we have that many blocks. What else do we have in the arena? An arena has an allocator, some number of blocks, some size of the blocks. Block size is arena block size. We can then say block storage will be a pointer. Then allocator user data arena allocator user data and function. Right, I believe. Yeah. So then for each block, we then want to say on B I so then from this block, we want to say arena block has a few things. We have the memory, the allocated, the capacity. Let's say memory is on B. I'm not even going to grab it. I'm just going to access it. Memory, allocate it, and capacity. %LB, block memory equals block allocated, and block capacity. Okay, memory allocated and capacity. Cool. So then what I'm going to do is after every allocation, we're going to LCA temp dump. So that should be LD, that's right. LCA arena there. That's 34. No. So seg fault. Because I never initialized it. Seg fault. Huh. Interesting. Let me first off move this shit up here, then I don't have to do this here. So seg fault. Result is 0. Block memory is 0. Block 256 allocated it's. Something is very wrong for sure. So this happened here, where I equals straight up 0. It's just blocked already, right off the bat. LCA arena push. Count. Count. 286. Blocks exists. So let me restart you. blocks. Memory and capacity both exist. Continue. Okay. Arena blocks. As memory. Step over. Okay. Block. No memory. It's there. Huh. This block doesn't have any memory. Nothing is allocated. Oh, because it's minus fucking 1. Build. Oh, and this is also fucking backwards. If there's less memory than we need for count. Okay. That puts us here. The result is some memory that exists. We can return. Continue. That do just be going. Yep. I mean, we hit the comma, and now it's broken. Are we hanging on a comma? Um, well, now what? Make sure it's built. Okay. Buildy. So now it's on bang. Percent amp star 1 2 1 2 1 2 pipe equals and minus. Now we're on equals, yeah. Plus colon semicolon comma. So now the kind is comma. Step over into over into over. Return trivia. One. Oh, because we're hitting a slash. So if we go into the trivia parser, it's going to see that we hit a slash, and there's no else at the end to return to exit the loop. So else, go to exit up. So we hit a bunch of invalid characters, but some of those characters were valid. Like down here, the calling convention cdecal. So that's 1138. If I click on here, 1138. Probably can't read it, but it is 1138. Current line 11, character 38. Type a line number between 1 and 14 to navigate to it. Well, we're on 11. Anyway, so that is the correct for that. Let's see what happens all the way up here. So we hit slash less greater question, and then we get comment, which then goes to colon colon. So it skips the comment totally fine. Is it a valid trivia? Who knows? We don't have a token print construct just yet. So let's really quickly print slightly better tokens. So we can write this token here. Then let's fprint f. Leading trivia. Only if. So if r count p token leading trivia not equal to 0, specifically I guess greater than 0, print the leading trivia. And then do the exact same thing for trailing trivia. So fprintf needs standard error. Always forget that. And we want this to be on a new line, on a line. Then for int count the token trivia, let's count that plus, and we can say Laye trivia t equals p token leading trivia sub I, and then we can say Laye c write note context p token, not p token, t location, and we don't have a toString for trivia kind, so I guess let's go write that real quick. Kind to string, now need a trivia kind to string mod s trivia kind to string t kind, which then needs to be followed by printf standard error. We're not printing the full anything, but let's do mod s new line. Not mod s, mod dot star s, and then stir expand pt text like that. And then we can do exactly the same thing for trailing trivia. Okay. And then we can say fprintf bunk. Cool. So now all we have to do is implement this. We can do that quite trivially. Const var. Oh, it's supposed to be called to C string. It is good. Trivia kind, switch kind, default, return, invalid Laye trivia kind, case Laye trivia, delimited comment, return, delimited comment, case line, up here. Line comment. Oh, we have a trivia kinds thing here. That's right. So in that case, just fucking trivia. Then we can build, and we can yoink. So for valid tokens, we now see that it's attempting. Hey, look, trailing trivia on question mark. After a question mark, we have a line comment. So now the only thing we need to do is in the parser for trivia, whenever we hit a line comment and we're not leading, we need to stop. So if not leading, go to exit. If it is leading, we can keep going. So then same thing here. We need to say we only want to exit the loop if we encountered a new line. So then bool new line encountered is false. Else, if the current car is equal to a new line, the new line encountered is true. Then we advance. So then only if we're not leading and we hit a new line do we exit this loop. Cool. Because now let's do a test on the very first token. Actually, we can make the very last token. Right, let's give it a plus. And we can say A, B, C, D, E, E. F we should not see anywhere. So for plus, we have a leading of A, B, and C, and we have a trailing of D and E, but we don't have F. The end of file token has F as a leading trivia, but we're not printing the end of file token just yet. We could print the end of file token if we just do the, it's down here. It's right here. So, well, token kind is not EOF. So let's just say, hey, file true, and then if this, right? This way it will print. It doesn't like me. Oh, double equals. So then here's our EOF, which has a leading F. Cool. But we don't need to see that, so we can go back. And we'll just leave it to this. We'll say git s git add dot git commit. I didn't separate out the fixes to the allocator. I don't really care. We're just gonna say parse simple lex simple operators and delimiters, as well as git push. Not the most well thought out commit, but hey yo, we've done the first two lines here. I'll leave that there to demonstrate trivia, but will not live forever. Now, we have a few options. Identifiers, keywords, and numbers are not bad. Identifiers and keywords are okay. The problem is this little boy. An identifier starting with a number. We'll have to, if we decide not to tackle numbers right away, then we need to special case out that failure if we start with a number but it doesn't turn into an identifier, basically. We'll just ignore it, basically, I guess. Yeah, ignore it. Because we don't want this to be an identifier. That's a number. And integer parsing, not terribly difficult, except for separate radices. I don't know if I have the brain power to handle those at the moment. I will probably continue streaming that tomorrow or Saturday, depending on what I'm doing Saturday. I don't know what I'm doing Saturday. Sometime in the next few days. I know we handled the easy, trivial case of tokens right now, but after debugging an arena memory allocator, I don't know if I've got it in me for the rest of the night. We did also do trivia. I didn't actually plan on doing trivia. It wasn't that complicated, but hey, we did trivia. So, oh, I actually just realized The whole point of grabbing trivia like this is for source compatibility reasons, right? We want to be able to preserve the comments in source code if we were ever to have this write formatted Laye code back to a file. Problem, I have already designed most of the syntax tree to discard tokens. So if we really wanted to make good use of this for code formatting, then we would have to add a bunch of information to the syntax tree. And the syntax tree is already 600 lines of code, and it's going to be kind of big on memory. So maybe, for the time being, we don't worry about... I don't know. Right, so here's thought process problem, right? I don't want to make it hard to write tooling for Laye, so I would like to think about a formatter, because that's part of the tooling that we're going to want eventually. But I really don't want to have to keep track of a bunch of tokens right now. But if I don't do it now, it's going to be a mess when I try to do it later, because I will almost certainly forget to do some cases. So, the reason that I'm hesitant, if you're not entirely sure why I'm like, damn, I don't know what I want to do. This node is already getting kind of big. All of these fields, plus all of these fields, plus anything else that's bigger, basically, becomes a very big syntax node. And we would have to store effectively every single token for every single kind of node. For example, this declared name here is the string that comes from the token that is the name of whatever this declaration is. So int a equals 10, this is the string a, because we declared a equal to 10. But I'm just using the string, I'm not using the token. So what this would do for us is we would have to find a place to put all those tokens, because we've stripped away all the token information. The only thing we have token related, basically, is the location of the most important token in the syntax node, but not the token itself. What we might do as a temporary, well, it would be a really shitty temporary if we just kept a list of tokens within the node. Fuck. I don't know, I'll have to think about it. Because maybe our maybe a code formatter would not want to be entirely syntax aware at the start. We could build a really simple formatter that's only token aware. But I feel like that would run into a lot of complicated edge cases trying to track when we're formatting things. Because most of the formatting rules you want are syntaxes instead of tokens. So this whole leading and trailing trivia thing may have kind of gone, not to waste, but to not super useful at the moment. I think we're going to wait to add token information and re-add it later. We'll keep it in the back of our mind that we want to know about tokens eventually. What we might end up doing then, if we care about tokens, is storing them all in an array and then pointing to the token through an index into that token array. I don't know. Yeah, didn't think that through. I don't think we're gonna worry about it. Simple answer, fuck tokens. We'll think about tokens later, or fuck trivia. We're going to keep them around because I want to use them to associate documentation with nodes. So like if we do, this is a variable in a equals 10, then whenever we hit a token, we can start storing its trivia somewhere. And for any relevant trivia to something that we parse, we can start storing it as like a doc string. We could say, hey, we've parsed a type. Every time we've parsed a type, we've concatenated any associated, like, well, when we start parsing a type, we say, hey, cool, here's the starting trivia. That's the only thing we care about, right? We don't really care about pointer a equals 10, right? So when you start parsing a type, store all of its trivia. If it turns into a declaration, then you can use all of its trivia to generate a document string for this declaration, right? That's the primary purpose of trivia. Secondary purpose is for code formatting in the future, which we'll figure out eventually. Okay. Let me take like 2 minutes to go get some water and walk around. And then I should be feeling fine and we can continue. And if not, I'll let you know. How do I say BRB? I don't have a BRB string. Be right back, please. How about that? Okay. Let's see how we're feeling. We want to start lexing. Let's do strings. I can commit to strings. Then. Yeah, we'll do that. We'll say pool is car is PSC. Yes. And we'll do exactly the same thing for both strings and characters, but if we get multiple characters for a character, then we'll just error and continue. So our terminator is C, our advance P. So now we're in the string of the character. So while speed is not equal 0, P car not equal to 0, and P current car is not equal to terminator, then P current car is not equal to terminator. Write an error for P context. This is where we need some location information again, so token location unterminated string or character 0. Is our character string, like that. So then let's come up to our... No, we don't need to do that. Let's create a dynamic array. If I do a dynamic array, that'll be fine. Yeah, let's say... Actually, let me take a look at the implementation I have for LCA stir. If I... We haven't done any appending. Okay, we haven't done any appending. If we just write string append, yeah, I'm definitely not going to get much farther than strings. I'm actually more tired now that I've got water. I can create from data, which is probably the best thing I can do. Yeah, for now, let's just say dynamic array of car string data is null. Then down here, array free of string data. But what we want to do is a string value, which we can put into token directly and say value equals string from data p context allocator string data counting capacity. So capacity this doesn't do what I think it does. I mean, it does do what I think it does. It doesn't do what I want it to. So LCADS, does it have capacity field? It does not. LCADA capacity capacity like that. And then down here, capacity. Okay. So then I can say our count of string data plus our capacity string data So then string from data is going to assert that it's null terminated. So what I'm going to do here is we're going to say our push string data 0. Then our set count string data, our count string data 1. And null terminate the string. So go. Else LCA car LCA Laye car advance P. If we did hit the terminator, skip the terminator. And then once we're done terminating, we break and we get all of our information. So all we have to do in here is say, look, car C is equal to the current character. If C is equal to this, then we got to do something. It's also just assert that C is not equal to terminator, so that we know that that's the case. If C is equal to this, then we got to do something. Else, we're going to push string data, the character that we're reading. And Laye car advance. Now we ow, my arm. Where am I going? Do this. Then switch C. Default R push push string data C in advance. I'll have to decide if I want that to be the case. I'll allow it, but I'll parse it, but I'll make it an error. Right. So the location here needs to be Laye C warn. Error. P context. The Laye C location should be source ID equals token location source ID dot offset equals P lexer position and dot length is 1 for thing valid character in escape sequence. Right. That does wonky stuff with the formatting. Okay. So that's good. That's fine. So then we want to handle the actual cases, like case N. Here, all we want to do is push the new line character, advance, and break. So then, if is car and string data not equal to null, before I forget, we're going to come over here and say that we want to do error car is false. We're just going to set error car is true. this means that we've parsed more than one quote-unquote character. A character could be multiple bytes, so we're just going to say, hey, on the second iteration, it fails here. So then, all the way at the very end here, after we've done a thing, I'm going to go ahead and do this anyway. Because then we're going to say, hey, if error car, then do this, -c write error, the context, token, location. I mean, like, what happens here? What is this error? That's not really. Oh, memset is not declared from LCADS. Right, that's string. Oh, it's not. Include the string header. I mean, I did. But I guess it's not looking for LCADS to rebuild. Hold on. I mean, it's trying. String. What? So yeah, I guess I don't understand character literals in C. If I say A has 97. S has 24947. A. This doesn't make any sense to me. FFFF. That's just a big number. What the heck is this? Free. Just need all three of those at all times. So too many characters in character literal. Now, if is car and string value token string value dot length now is equal to 0, do this shenanigans again. Not enough characters in character literal. Good enough for me. Build. It likes to build it, build it. So I'm intentionally not finishing out anything other than n, so I just want to make sure that it says invalid for the rest of them. So if I run, token kind, because I never set the token kind here. So if is car, token kind is Laye token that's what we're calling it. Else, let string So it's not a character literal, it's a rune literal. Okay, so we have lit rune at 23 in our string here. 23, that's 0. And that's for this lit rune here. Actually, wait a second. That location information is wrong. This one should be on 20.0. Location information is very close to correct. Interesting. Well, now, context, get location info. What happens if I do that? That's at 21. Good. So at 1917, that's here. Yep. 2019 plus should be on 16.1. It's not though, it's on 1166. What the heck? Oh, well that I know why. Because this. Now we want to start. Do it again. There, now it's on 16.1. Cool. Well, now we've got most of literals for strings and shit. Let's do the rest of these. So if I say A, does A exist? If I say B, B should exist. If I say DE for a form feed, does F exist? DHI JKLM OPQR ST UV WXYZ 0. I'm explicitly not doing hexadecimal stuff or Unicode stuff just yet. So this should remove all of our invalid character and escape sequence because I forgot backslash and both quotes. We can make the lab either way. Cool. Now we've handled all of our escape sequences. We're not printing the values yet, but that might be fine. So then all we've got now for real is numbers and identifiers. Numbers and identifiers. Which I definitely think I should do later. So I'm going to call it there. We're going to git s git commit that string literals git push. Alrighty, that's the end for tonight. Half decent progress, half a lexer done. Anyway, don't forget that you can join the Discord where I talk about this and other people talk about whatever the hell they want to talk about. Links are in the description. You can also view the project source on any of the 4 mirrors that are in the description. There's GitHub, Codeberg, GitLab, and my own Git instance. So you can go look there, fork there, contribute if you want. Probably if you're going to contribute, do it on GitHub. It's the one I'm most familiar with. I may or may not bother to look at pull requests, especially this early on. Probably not, so maybe don't contribute just yet, but maybe learn the source code, and when I do start opening contributions, you'll be ready. I don't know. I'm rambling because I'm tired. Thanks for stopping by, and good night.